Another DP problem today. Maximum product subarray.
Given an integer array nums, find a subarray that has the largest product and return the product. The test cases are generated so that the answer will fit in a 32-bit integer.
I pre-read this a little bit before, and I was, sitting on it a little bit. And one thing that stands out that they didn't, I guess they did say, but you kind of have to just look, because unless you know the definition of a subarray, which I kind of do, but it means that all of the numbers that you're going to be multiplying, basically, have to be next to each other. And let me show you an example of what I'm talking about. So when it talks about subarrays, it means, say for example, this here's a subarray, or this here's a subarray. The numbers have to be adjacent to qualify as a subarray. So we obviously couldn't group 2 with 4 because this can definitely be done in linear time. I don't see why not. I wouldn't see why this would take any longer. Like, you could literally just do this through one walkthrough. One solution to like these DP problems that I've been seeing a lot is doing a bottom-up approach, which is, I think in my head, correct to what I'm trying to aim for. Like, start at the front, obviously. We obviously have a cache. Let me change pen colors. Oh shit. We obviously have like a cache or something where, let's just call it DP, where all of these numbers, every index is mapped to a key value pair inside of the, we could do a hash map. I don't necessarily think we need a hash map though. We could also just do an array, right? Each index maps to the index in the array. So just initialize one with like a bunch of the zeros or whatever, yada yada, and then we just update as we go through. So say for example, we're at the first, we could calculate the max at this index. So 2, only thing here is 2, right? There's nothing to multiply it from previous. I think we should have like a variable to store the previous max product, and we could initialize this to, let's say 1, to take care of this case here where the first number that we iterate over should be it's its own max, I guess. So like, say for example, you had like you had a 2 in here and you just had a bunch of zeros, right? I don't know if I'm not fucking making sense right now, but let's try it out. So max 2, and like, what are you be comparing it to? 1? Obviously it'd store as a 2. Alright, you store as a 2, you go to the next one. Now at the second, I think now we update res to 2. I think that works, because this works for this test case, but let's use another one, for example, with the same line of thinking, because what I'm afraid that will happen is we'll find like the max product in the front of the array when it's really in the back. This, and then the product, right? Because there's like 3 different things we could do here. We could either update this to be, or not 3. You could either update this to be update it to be 4, or 2 different things. Update it to be 4, which is itself. That's to say that the product that came before this isn't bigger than the number itself. Or you could multiply these two, which would become -8. I think those are really the only two choices we have here. So we first said that we need to obviously like a cache. I don't know if cache is the right word. A max result variable. I don't even think we need a max result variable. Because, okay, yeah, dp if dp at I minus 1. And we can do this for the first iteration because remember, we're offset by 1. So we're just checking basically the first index here. -1. Oh, this is what I forgot about this. What seems to be happening is that we are getting our, like, this is our max here this is the max subarray, product subarray, but it's being like overwritten. Like you're basically just losing it in all of the different iterations. What I was hoping for was that by the end, our max would end up at the last index, and we can just return our last index of our cache. But in this example, let's follow the same logic that we were coding before. 2, we're comparing the index before the index we're on, so I minus 1 in dp, and I in our array. So it'd be 2 times 3. Is that greater than or less than 3? It's greater than, so this gets updated to 6. Right? It's all good now, but when we move on to the next one, now we're looking at -2. It's 6 times -2. Is that greater than or less than? -2 less than. So this gets updated to -2, right? Which is wrong, but it's not necessarily what we wrote it to do. We want to store this, so I'm thinking we can just have a variable that calculates the max each time. What it should calculate, that's a good question. What should it calculate? I think it calculating the product 1. So obviously the product, which we said was dp at I minus 1. And what did we say? Just nums at I. Everything else seems to be fine. I think just our problem right now is storing this max product. Yeah, I think because this should come afterwards. We should update the result variable afterwards, after this has been updated, right? So after we do this logic, and we update dp at I, we should then compare this. We should compare whatever the result variable is right now and our new biggest, quote-unquote biggest number that we have in cache. 80, I guess. 80 is kind of a lot, but 100 is a pretty good amount already. So that means we're somewhat close. Okay, so expected, that's technically, when we're iterating, we have the number we're iterating over, right? We have, so let's say 3, and then we only ever need the most previous number, most previous max product, which is stored in res. So I genuinely think we can get rid of this. There's no point in it. And if that's the case, then I mean, it kind of frees up more stuff. So I peeked at the solution a little bit because I mean, it was like an hour, and I felt like I was in the same spot. I didn't really know what the next step was. I didn't feel like I was getting closer. But I was slightly off. I think I was more on the target with my first thought process. So one thing I didn't really account for is how negatives can affect this. So let's say say we just considered -1, just like before, where we're building we're building our subproduct array based off of previously computed values. We have -1. This is our biggest right now, right? Now we're considering -1 and -2. We want to see, just like before, if -1 is greater than or equal to -2. And when it is, because this is greater, I think what we did was we multiplied both, if I remember correctly. We multiplied both, and this is our max, right? But like I said before, we also want to store our minimum, which is -2. And this is useful because it takes into account the negative sign, right? So it's easier with an example. Let me just show you. So now that we have this computed, let's now consider -3. So we set our max. Let's consider both our max and our min. So our max was 2 and our minimum was -2. And we want to compare these two. We're comparing this and this. We're doing 2. So which one would give us a max out of these two? Obviously, -3 multiplied by a positive will just stay negative. But because we store a minimum here, now this negative cancels out. And this gives us the actual solution to this problem. Okay, with that in mind, I'm gonna get rid of what we had here, because we do need the cache for this. Or let's try to implement this without the cache, because I really don't think we need it. Like, we're literally just spamming max functions, bro. Oh my god, I feel fucking brain dead. Close. So we ended up doing it. I did this off camera because I was genuinely 2 hours in and I did not want to fucking record anymore. But I did peek at the solution a little bit, and I was pretty much on the mark with the whole comparing. I obviously did get some pointers about storing the max and min, but only thing I was really missing was, once you do get your max and min, you also when you are comparing, when you're multiplying the number you're on by the max and the min, you also want to consider the number itself to be a candidate for your max or your min. And we did that here. Everything else is basically the same. I just broke down the max and the min into 2 variables instead of a tuple, and kept pretty much everything the same, like I said. But yeah, this problem was pretty fun. I think this is one of those problems where it's a very memory efficient, because I did start with using like an array as a cache, when I think technically this is a cache. Like, you're technically caching these 2 variables, but I think, I mean, I could be wrong, but I think when you're just storing one variable, it's constant memory. I hope this was helpful. I think I definitely enjoyed not peeking at the solution right away. Like, I felt much better. It felt like I actually learned more, and I think I will do this more. Even if it'll be a longer video, I will see you. I'll make another video in probably like 2 weeks. This weekend, I'll be at Hack Princeton, so I will have my hands full. Thank you for watching.